Glad to be here and very happy to see a vibrant machine learning community here in Toronto. This is my first time visiting here and I really like the city so far. All right, in this presentation, at DoorDash, we've been building our machine learning platform for the last 2.5 years now. And in this presentation, I would like to share a little bit about our journey and a few principles that we use to help with scaling and evolving our machine learning platform. So I'm currently working at DoorDash, different introductions, and been at the company about 2.5 years. Before that, I was at LinkedIn and spent a little bit of time at Uber. So machine learning plays a pretty big role at DoorDash on the DoorDash platform to help with improving customer experience, making business decisions, reducing costs, and so on. So to give you a glimpse of that, I will walk through a small set of ML use cases through the food ordering process. And then we're going to the meat of the presentation is what are some of the principles we use for scaling and evolving our platform. And then wrap up with a little bit about the current state of where we are and what does the future look like for us. So our mission at DoorDash is to grow and empower local economies. And we do that through a set of product offerings. All right. And these are the products. First, we have the restaurant delivery and pickup, and probably many of you are familiar with. And then you can also use the convenience and grocery product to order non-food related items, such as sunscreen, which might not be a popular item in Toronto at the moment. And then we have DashPass, like a subscription product like Amazon Prime, as well as B2B fulfillment of logistic fulfilling for some of their larger margins. So if you have ordered food on DoorDash before, this food order lifecycle should be fairly familiar to you. But out of curiosity, can I get a show of hands if you have ordered food on DoorDash before? All right, about 75%. Hold your hands up once a week. Wow, okay. Not that many, so. All right, good to hear. Good to see that too. So as I walk through each of these steps, we're trying to highlight the machine learning use cases. So the first one is creating order. So when customers land on the homepage of DoorDash, we want to surface the most relevant and personalized food items and restaurants for our customers, right? So they can order food and whatever. There's a set of ML model behind that to help with the recommendation in terms of learn to rank, universal ranker, and using explore and exploit kind of approach in the recommendations. And if customers can't find or don't find any items that they would like to have, they can go and do the search, go into the search box and type in what they would like to have for breakfast or lunch or dinner and such. And that's where another set of ML model comes in to help with the ranking to show the most relevant results. And finally, at the bottom of this slide here is talk about promotions. So DoorDash has an ads and promotion business. So there is another set of ML models to power the ads targeting there. And once the food order items been added to the shopping cart, then on this page we'll show the ETA, right? How long does it take for the food to arrive? And ETA is kind of tricky because if we code it conservatively, meaning too long, then you might not want to order that food for dinner, for example. But if we code it too optimistically, then the food might be arrived and you might not be happy. So it's a tricky business. So we want to share pretty reasonably accurate predictions. There's a number of factors that go into those models to estimate the ETA, including the size of the shopping cart, the store operating hours, and how many dashers are available at that point in time, for example. And another set of use cases around fraud, right? We are another internet e-commerce company, so we want to make sure to deal with the fraudulent transactions and activities and so on. And next. All right, so once the food order items have been added to your shopping cart and paid, then the next part is where our logistics engine kicks in. It essentially sends the order to the merchants for them to prepare the food, as well as assigns to the dasher. And the primary role of the logistics engine is to maximize the marketplace efficiencies. And it does that by depending on a set of models to providing the estimation for how long would it take to prepare your food, right, based on what you order and all the other parameters. And then also how to assign to dasher to pick up the food. And there's a lot of nuances here in terms of the traffic, right, the weather. Those are the things that we don't have much control of. So it's quite interesting in these use cases. And the other interesting factor is like, food orders emerge on the fly, unlike Amazon order that you order for your home and stuff like that. So, the food quality is very important as part of the food delivery process. So like the extra 5 minutes could be like the big difference between a great meal versus a bad one. And finally, on the final steps, where delivering order, and we use machine learning to forecast the demand volume, and that drive a lot of business decisions in terms of how much we want to provide incentives for dashers to mobilize them to show up at the right time and right location and so on. And another use case is during the pandemic, we introduced the contactless delivery. So you may have seen where a dasher will take a photo of the food at a drop-off, right? So we use machine learning to detect if that indeed happened, for example. So now you're armed with all these machine learning use cases. Now let's talk about some of the principles that we use to scale and evolve our machine learning platform. And these are, we will walk through 3 of these. Dream big, start small, 1% better every day, and customer focus. These principles work fairly well for us because they really align with our culture values. And you might detect some similarities between these and Amazon's leadership principles. And one of the reasons is our CEO is a big fan of Jeff Bezos and also has Amazon. All right, let's go into the Dream Big, Start Small, which consists of 2 parts that I call it. The first part is about Dream Big, which means that in the context of building a machine learning platform, you want to start out with a vision of where you want to go, right? What you want to build and all that stuff. But the second part is what I call strategic bets, meaning that the way you approach to building your ML platform may be different from another company. And it's going to be driven by the kinds of use cases at your company and the culture and all that good stuff. So they influence the way you think about which components of your ML platform is more important than others. So that's what I call strategic bets. And for us at DoorDash, it's about velocity. How do we help data scientists to get the model to production quickly? And how do we want to build our platform as a service, such that all the components work very seamlessly together from the users, from our data scientist perspective, right? And finally, it's about committing to ML observability, right, to protect the downside. Once the model is in production, we want to make sure to monitor and alert if the model starts to degrading. So that's the dream big part. And the start small, it's a pretty important part of this as well, because it encourages us to think about how to make incremental progress and impact, right? Because building an ML platform might take a long time, but that might not work for a young and high-growth company like DoorDash, for example. So as a platform, how do you demonstrate that? How do you demonstrate value and impact to the company in a short amount of time? And I'll walk through an example how we did that in the beginning, which is about building a centralized prediction service and a feature store. So the story goes is logistics team is one of the earliest teams at DoorDash that leverages machine learning. And during the beginning of the pandemic, their prediction service had challenges in keeping up with the growth of the company. And at the same time, that's when DoorDash decided to build a centralized machine learning platform. So we partner with that team to understand their needs, their use cases, and then start building our prediction service with the feature store. And a few design decisions that has helped us quite a bit since then, including a centralized prediction service, right? You can have a model where you have one endpoint per model or one endpoint for all the models on your prediction service. We chose the latter because we believe that will give us much better machine utilizations, for example. And then the second one is about the ability to shadow model. That has become really, really useful for like shadowing the traffic and use the prediction logging for training models and so on, as well as testing the models. And to deal with latency, we support like batch prediction. I think that's pretty common now, but it's really useful for like recommendation use cases. And finally, we leverage the C++ layer at the prediction, actually making the prediction to really speed up that part. So with these sets of features, we were able to onboard the use cases, the logistics teams, and at the same time, we were able to make meaningful contribution and impact. What's next is quite interesting. Once we earned the trust of that team, another team came to us, which is the search team, the search and ranking team. And their use case is quite a bit stricter in terms of higher QPS, lower latency, and also in the path of the user interaction on the websites. So it's highly visible use case. But with our design, we're able to onboard that use case, but there's some interesting challenges along the way. One of them is because of the centralized prediction service, we ran into something called noisy neighbor effect, right? Some of their models are quite large and high QPS, and that start impacting other models. So what we did was we essentially moved those noisy neighbors into their own cluster, and then using a sharding model approach. And we're able to scale our prediction service to support both of these use cases. And our QPS that we support is in the order of 1 million plus at the moment. Then the next very big use case came along, which is all about recommendation. Like I talk about how on the homepage, the user land on that, and there's many, many predictions going on there, right? Personalized as well. And this is gonna lead to the next principle, which is about 1% better. So this principle it's about, it's not trying to be perfection in terms of building a platform, but the key thing is the mentality of a constant refinement, right? To make it better every quarter and so on. So the question is, how do you know what to improve and when to improve? Okay, so one way to do that is you need to have a way to track what's going on, what are the changes, understanding the trends and so on in terms of what's going on in your platform. And for us, we have a set of metrics that we track on a weekly basis, some of the key metrics. And one thing that pop out for us is the feature volume, the feature value volume, as it was being increased dramatically. And we scale up the clusters, and the cost kept increasing. So we recognize this is an area that we definitely want to get better. We definitely want to improve on this. And the team stepped back and decided to invest some time into improving our feature store. So based on the learning from the use cases that we onboarded, as well as the experience that we have, the team came up with a sets of requirements in terms of what our next version of the feature store might be, include the ones that's listed here. But what's more important is our goal is about improving CPU utilization and reduce memory costs, usage. And that has direct translation to reducing costs. So I'll go through some of the optimizations that the team came up with. The first part is essentially, we use Redis as a feature store, right? And so there's like billions of key values. So the first optimization that we did was redesigning the data structure to store the feature values. So essentially co-locate related features values of a single key together. And the added benefits is all these feature values of the same key resides on the same node. And therefore, that would eliminate the need to scatter in terms of your requests during a prediction. So that's one optimization that the team did. And that certainly helped improve the CPU utilization in this case. And the next part to reduce the memory usage is about encoding the feature name. And we use a pretty verbose feature name, such that if someone reads the feature name, I have an example there, they can understand what that feature is about. But putting that in Redis is quite expensive. So the team decided to encode that from 20 plus bytes into 4 bytes, using a non-cryptographic hash function to do this. And with millions of features, and so hundreds of millions of features, and this certainly has helped reduce the memory usage quite a bit. And the last step, which is not on this slide, is we actually compress some of the feature values. Okay? Some of the complex feature values like sequence or lists of IDs and something like that, we actually compress them. And that also helps reducing the memory usage. And as a result, you can see here on the memory usage, we're able to reduce by 3x, as well as improve the CPU utilizations roughly about the same factor. And that has a direct translation to the cost reduction. And the other cool thing was it actually improved the latency by about 30%. And with all this optimization, we were able to successfully onboard that recommendation use case. And the last principle is about customer obsession. And this is one of my favorite ones, because it actually leads to positive outcomes, and some of them are unexpected. And as we were building the ML platform, we tried to really understand our customers' needs and also try to anticipate their needs. It's not easy, but I believe that it's something worth shooting for. So I'm going to read this, and I want to talk a little bit about this. So with customer obsession, you're not just listening to your customers, you actually also invent. You're also inventing on their behalf. I didn't come up with this. This came from one of the blogs about the day one mentalities at Amazon. Okay? It also talks about even when customers don't even know it, they want something better. Right? So as an ML platform, if you have the desire to delight your customers, that will drive you to invent on their behalf. So the example they gave was the Amazon Prime membership. And maybe some of you have this, right? But you probably didn't ask Amazon to invent that on your behalf. So I think it's pretty cool in terms of this mentality. For us, right, providing good customer support, I believe, is one of the ingredients of a successful ML platform. So therefore, we want to support our customers in the way that we would like to be supported. That means that we want to commit to providing support promptly, with fairness and respect. right? But at the same time, you got to strike the right balance between unblocking your customers and being overwhelmed with the support loads. So you have to have that constant evaluation of the amount of support load and what kind of support are those. And then make the kind of investment in terms of tooling, automation, whatever that might be. So the example for us in this case is like earlier this year, to deploy a model into our platform, it actually required a pull request. It works. It has some small friction, but it works. But as the number of data scientists increases in the company, it became a burden for the team. So we should invest some time in automating this and turn it into a one-button click and still have all the safeguards that we want from the PR, the original ID. Delight your customers with French fry moment. Just curious, how many of you have heard this concept? Wow, not a single hand. Oh, maybe one in the back. Okay. I love this concept. This came out of Google, by the way. And this concept encourages us to tap into our creative thinking, right? To delight our customers with solutions without them prompting from us. That's the key thing, without prompting from them. That's how you come up with French fries moment. And I constantly strive to encourage this on my team. And what's another cool thing is sometimes the solutions that you come up with, actually you end up benefiting from them as a platform. So it's a win-win kind of thing. So as an example, on our platform, it used to be that if you want to test the model predictions, it required like a script, right? Running a script. And we provide a lot of instructions, and data scientists can do that, and they're pretty happy with that. But as more and more data scientists join the company, and some of them are not fluent with scripting, so without any prompting from our customers, we went and built a simple web-based application to help automate this. And it was a huge win. And what's really cool is this web-based application has turned into a product that we call ML Portal, which becomes a single destination for data scientists to go to do most of their ML work nowadays. So that wraps up the 3 principles that we talk about: dream big, start small, 1% better, and customer focus. In terms of where we are currently, if I can advance the slide. All right. So this shows the trends of the number of models on our platform, as well as the prediction volume. This is something we're pretty proud of, but another thing that we're also proud of is the adoption across the many teams within the company. So not just 1 or 2 teams, but also all other teams in the company, essentially, that depends on machine learning. All right, let's go into the last part. It's the future looking. What does that look like for us? There are a number of things that we are going to be working on in 2023. One of them is supporting large and complex deep learning models. Data science, we have a lot of tree-based model, but some of the use cases, according to data scientists, that they're kind of maxing out the performance of tree-based model. So they want to explore these complex deep learning models. So as a platform, how do we support that from end to end, right? Doing distributed model training, large model hosting. Some of the use cases in NLP, you know that the model is very, very large. So how do we support that on our platform? And the second thing is ML observability. Right? I mentioned this as one of the key bets of our platform. We have kind of a point solutions, but we don't really have a cohesive story around this. So we're definitely going to double down on this to protect the downside. Right? Now we have a lot of models on the platform. If their performance starts to degrade, that has real business impact. And along with that is how to make it easier to do continuous model training now that we have a sizable number of models on a platform. And we want to do this in such a way that with minimum human intervention from end to end, right? Not just training a model at a certain interval, but the ability to set criteria, the ability to roll back, and all that good stuff. So that's our goal in this area. And finally, efficiency. Cost has become the top of mind for almost every company nowadays. And when we start operating at scale, right, any small improvement or reduction in terms of cost, it's a huge win. So we have to look into how to, maybe there's some feature duplication, we want to reduce that. Maybe in our prediction service, how do we scale, not scale, but how do we scale down our prediction service based on the traffic pattern a little bit more intelligently? And that's going to be a huge win there when we actually get that done in the next couple of quarters. Whoop. And that's it for my presentation. So thanks everyone for listening. We have about 3 minutes, so if there are questions, I'm more than happy to take a few.
Thank you for thank you for that. If you have a question, please raise your hand, and one of our mic runners will bring the mic to you.
Hi there.
Question right here.
Oh, okay.
Yeah, go ahead.
Thank you for a great presentation, which was very detailed, so that was refreshing as well. I was wondering, as you have new users who come on board, do you use any kind of transfer learning as a way to rapidly create their profile?
I'm sorry, I think the question is about as we onboard customers?
Yeah, like how do you optimize rapidly creating their user profiles, maybe through transfer learning or any other mechanisms?
Oh, you're talking about the DoorDash customer profile? Yeah, not quite sure about that one. Maybe we can take offline in terms of to better understand exactly what you mean by the second part. So let's talk offline that one.
Thank you for the presentation. I'm wondering if you can talk more about the feature store optimization.
Yeah. Sorry, what? I heard the feature store optimization, but what's the question?
Could you elaborate more on how to optimize the feature store?
Oh, how? Okay. Well, I think in terms of what was shared there, the goal there was to improve CPU's efficiency and reduce memory usage, right? For us, it's because we use Redis, everything's in memory. So the more features you dump on there, then you have to scale up and the cost kind of exploding. So in terms of memory reduction, there was some optimization that I shared in terms of using a hash data structure, so storing related values into a single key. That's one thing. And then encoding the feature name, right, from 24 character or bytes down to 4 bytes, for example. And then the last part was about compressing some of the feature values based on the type. We cannot compress everything, but for certain feature value types, that can be easily compressed, then we take advantage of that and do that. So those are there's a blog, by the way, when you get to the slide deck or the presentation, there's a link to a blog that goes into details about the various optimizations in addition to what I just shared.
Hello, thanks for the presentation. What I understood from you is that you guys are using one endpoint to serve all the models. And I assume that you have like tens of, perhaps hundreds of models. In this case, do you guys keep all the models warm, or does this approach increase any latency?
So the question is, with a single endpoint for all models, what was the second part?
So I wonder if you guys are keeping all models warm, meaning they are ready to serve and they are ready to predict, or do you need to warm up the model when there's a new request?
Oh, yeah. That's a great question. Yeah, and sometimes when you build your prediction service, and if there's a new model, you might end up doing a redeployment, right? That's one way of doing it. But the better way is to hot load those models as you have changes. So that's also part of the features that we built into our prediction service. So deploying a model is simple as like click on a button, and in about 10, 15 minutes, our prediction service will pick that up and then load it into our prediction service without any redeployment at all. Is that your question? Okay.
Yeah, I mean, I think so. So you guys are basically keeping all the models warm, so they are ready to serve.
Yeah, we have a model store.
Yeah, gotcha. Okay, thank you.